So we have some examples as promised of permutations and combinations. How many ways are there to pick a president, vice president, and treasurer from a club of size 65? And I want to use permutation and combination notation. So that means I have to pick one person to be president, one person to be vice president, and one person to be treasurer. That's like picking three people and placing them in order. So that ought to be from 65 permutation 3. So take the 65 and put them in order. I'm going to do it on here. Am I? Or I could do it another way. Let's just do 65 for president, 64 for vice president, 63 for treasurer, like that. So that's 65 times 64 times 63. That's a big number. 262. 080. 262,080. How many ways are there to choose 4 of your 30 friends to go hiking with? Well, now there's no order to those friends. You're just going to pick a group of friends. So we're going to go 30. We're going to choose 4. And we said the formula for that was 30 factorial over 4 factorial times 26 factorial. These two add up to be 30. And that's a little bit cumbersome, but a lot of things cancel. So 30 times 29 times 28 times 27, then everything else cancels. 4 times 3 times 2 times 1, like that. And then things will cancel, it turns out. Although, what should we do with their canceling? 27 is 9 times 3. And then 4 into 28 is 7. And 2 into 30 is 15. So I get 15 times 29 times 7 times 9. 15 times 29 times 7 times 9. 15 and 20 is okay. 27,405. Well, you have a lot of different ways of going hiking, that's for sure. Let me just double check that. So I'm going to type in 30. I'm going to math, over to prob, down to NCR, enter, hit 4, enter. 27,405, we win. How many ways are there to select 4 of 15 fancy restaurants to try? We're just picking them. We're not putting any order in them, so it's going to be 15, choose 4. And as long as I'm in business here, 15, math, prob, NCR, 4. 1365. What are the number of ways to select 4 clubs of 24 to join? 1 as a freshman, 1 as a sophomore, 1 as a junior, 1 as a senior. So if you're paying attention to when you do what, and you figure out you pick the 4 clubs, but one of the clubs assigned to your freshman year, and then sophomore, and junior, and senior, and you're making those feel like different selections if they're offered, if you sign up for them at different points in your school career, then that's like having an order. So I'll go 24, P4, and then I'll use this one here. So I hit 24, math, prob, P4. 255,024. 255,024. That's a lot. But you know, you've got 24 choices as a freshman, and then 23 times 22 times 21. Let's make sure 24 times 23 times 22 times 21 choices. 255,024, correct. And then we're going to try to figure out the chance of winning the lottery using a strategy. So using counting and equally likely outcomes to get probabilities in the lottery. So in the lottery, this particular lottery question is about picking 6 different numbers from 1 to 36 where the order doesn't matter. So pick 6 to match the drawing. Alec, you figured out 1,000 of your favorite choices of 6. That's a lot. I don't know how you would do it. 1,006 choices out of 1 to 36. And 4 tickets cost $1. So to go for the 1,000, you're willing to spend $250 to give yourself a good chance of winning the lottery. It's only 6 numbers from 36. How hard can it be? And 4 tickets cost $1, and so I'm going to buy $250 worth of tickets. That'll be 1,000 different choices of numbers. How long is that even going to take me standing at the cash register or at the lottery ticket machine, just typing in 1,000 6-digit numbers? That'll probably take a couple, 3 hours. But it's probably worth it if you win. So the chance you would win is the 1,000 tickets you're willing to invest divided by the number of possible tickets. So if you bought half the number of possible tickets, you'd have a 50% chance of winning. Here I'm buying 1,000 of the possible tickets, so it's 1,000 divided by the number of tickets. The number of tickets has to do with choosing 6 out of 36. So I can use 36, choose 6 as my denominator. And that's a pretty big number. It's just about 2 million ways. So 1,000 divided by 2 million is 0.0051, whatever. So that's about 1 in 2,000. Is that really right? So I have to take 0.005 times 2,000. I'm supposed to get something like 1. I do, I get 1, okay. 1 in 2,000. So you spent $250 to have a 1 in 2,000 chance. That's not a very good chance. You go, well, why don't I just buy a lot more tickets? Well, the thing about this one is, if you want to stand a good chance of winning, you need to buy a lot of tickets. You need to buy maybe half of these tickets. So we'll try that. Let's try buying half of them. 1947792 tickets. Divide that by 2. That's about 1 million tickets. You get 4 for $1. Divide that by 4. That's how many bucks it's going to be. So for about 243,000, you can own half the tickets. So for $250,000, you get half the tickets. It just depends on what the prize is, whether that's worth it as a gamble. Because what if you lose? You're out $250,000. So that's a challenge question. Would you be willing to do it? Say, spend $250,000 to have a 50% chance to win $1 million. You'd also have a 50% chance to lose that $250,000. So I don't know the answer to that question. That's up to you and your bank account and your accountant. But here's some ways of using permutations and combinations to count other things you might think about and to estimate your chances of winning the lottery using 1,000 tickets. There you go.